Do you know how to divide mixed numbers? That's what we're learning in today's lesson. These are the steps in dividing mixed numbers. 1. Convert mixed numbers into improper fractions. 2. Change into a multiplication problem using KCF or keep change flip. 3. Multiply the numerators. 4. Multiply the denominators. And number 5. Simplify or reduce the fraction. Here are the 6 examples. Give it a try and play the video whenever you're ready for the solutions. Question number 1. 3 1/2 divided by 4 over 9. Step 1 here is to change mixed numbers into improper fraction. Can you recall how to do that? In converting mixed number to improper fraction, we multiply the denominator 2 by the whole number 3, which is 6, and then we add the numerator 1, which is 7. So we will have 7 over the denominator 2 divided by 4 over 9. Step 2, we will transform this into a multiplication problem using the KCF. We keep the first fraction 7 over 2, we change division to times, and we flip 9 as 9 over 4. Step 3, we multiply the numerators 7 and 9, that's 63. Step 4, we multiply 2 and 4, and that is 8. Now let's simplify this fraction. How many 8s can go into 63? 7, right? 7 times 8 is 56. And if you subtract 56 from 63, you will have a remainder of 7. So we will write the remainder as 7 over 8. The final answer is 7 and 7 over 8. 8 times 7 is 56. 56 plus 7 is 63. So that is the same thing as 63 over 8. Question number 2. 3 2/3 divided by 1/2. Step 1 is to change mixed number into an improper fraction. And we can do this by multiplying the denominator 3 by the whole number 3, which is 9, and then we add the numerator 2, which is 11. So we will have 11 over 3 divided by 1/2. Now we will change this into a multiplication problem using KCF. We keep the first fraction 11 over 3rd, we change division to times, and we flip 1/2 as 2 over 1. Next, we multiply the numerators 11 times 2, and that is 22. We multiply denominators 3 and 1, and that is 3. What do you think is 22 over 3 as a mixed number? The mixed number equivalent is 7 and 1/3. How many 3's can go into 22? 7, right? 7 times 3 is 21. And if we subtract 21 from 22, there is a remainder of 1. And that is why we write that as 1 over 3. So the answer for number 2 is 7 and 1/3. Question number 3. 2 1/3 divided by 1 3/5. Step 1 is to change mixed numbers into an improper fraction. Let's begin with 2 1/3. 3 times 2 is 6. 6 plus 1 is 7. So we will write this as 7 over 3. Divide by. Now let's change 1 3/5 into an improper fraction. 5 times 1 is 5. Plus 3 is 8. So this is 8 over 5. Next, we change this into a multiplication problem using KCF. We keep the first fraction 7 over 3. We change division to times. And we flip 8 over 5. And that becomes 5 over 8. Now we multiply the numerators 7 and 5. And that is 35. We multiply denominators 3 and 8. And that is 24. Now we will change this improper fraction into a mixed number. How many 24s can go into 35? 1, right? 1 times 24 is 24. And if we subtract 24 from 35, there is a remainder of 11. So we will write the remainder as 11 over 24. The answer for question number 3 is 1 and 11 over 24. Question number 4. 5 and 1/3 divided by 1 and 6 over 7. Step 1 is to change the mixed numbers into an improper fraction. Let's begin with 5 and 1/3. 3 times 5 is 15. 15 plus 1 is 16. So this is the same thing as 16 over 3. Divide by, what is 1 and 6/7 in improper fraction? 13 over 7 is correct, because 7 times 1 is 7. 7 plus 6 is 13. So we have 13 over 7. Now let's change this into a multiplication problem using KCF. We keep the first fraction as 16 over 3. We change division to times. And we flip 13 over 7 as 7 over 13. Now we multiply the numerators 16 times 7. 16 times 7 is 112. Now let's multiply denominators 3 and 13, and that is 39. How many 39s can go into 112? 2 times. 2 times 39 is 78. And if you subtract 78 from 112, the remainder is 34. So we will write the remainder as 34 over denominator 39. The answer for question number 4 is 2 and 34 over 39. Question number 5. 5 and 3/4 divided by 4 and 5/8. Step 1 is to change mixed numbers into improper fraction. Let's begin with 5 and 3/4. 4 times 5 is 20. 20 plus 3 is 23. So that is 23 over 4. Now let's change 4 and 5/8 into an improper fraction. 8 times 4 is 32. 32 plus 5 is 37. So we have 37 over 8. Now let's change this into a multiplication problem using KCF. We keep the first fraction 23 over 4. We change division to multiplication. And we flip the second fraction 37 over 8, making it 8 over 37. In this problem, we can reduce the fraction 8 over 4, and that is 2 over 1. So now we multiply the numerators 23 times 2, and that is 46. Multiplying 1 and 37, we have 37. How many 37s can go into 46? 1, right? 1 times 37 is 37. And if we subtract 37 from 46, the remainder is 9. And we write the remainder as 9 over denominator 37. So the answer is 1 and 9 over 37. Question number 6. 4 and 3/10 divided by 1 and 1 over 6. Step 1 is to change the mixed numbers into improper fractions. Let's begin with 4 and 3/10. 10 times 4 is 40, and 40 plus 3 is 43. So we will write this as 43 over 10. Next, we do the same thing with 1 and 1/6. 6 times 1 is 6. 6 plus 1 is 7. So we will write this as 7 over 6. Now let's change this division into a multiplication problem using KCF. We keep the first fraction 43 over 10. We change division to times. And we flip 7 over 6 as 6 over 7. In this problem, we can reduce the fraction 6 over 10. Both of them can be divided by 2. 6 divided by 2 is a 3. 10 divided by 2 is a 5. So 6 over 10 is the same thing as 3 over 5. Now let's multiply the numerator. 43 times 3 is 129. 5 times 7 is 35. What do you think is the equivalent of this as a mixed number? The answer is 3 and 24 over 35. How many 35s can go into 129? 3. 3 times 35 is 105. And if we subtract 105 from 129, the remainder is 24. So we will write 24 over the denominator 35. So the answer is 3 and 24 over 35. Thank you for watching, and please consider subscribing to my channel at Celzo Academy.